Hello, good morning. Am I audible?
Yes, sir.
Okay, we will start. So here in last class we have seen that conventional encryption principles, right? In that one we have seen some ingredients for that encryption process, right? And yesterday we missed this diagram, but this diagram is called as an conventional encryption model. But this diagram is called as an conventional encryption model, but right. So when they are ask you to draw that diagram, or when they are asking for that conventional encryption principles, right, along with that model, then you can draw this diagram, right? So here on left hand side two things are there, and right hand side two things are there. But on left hand side we are encrypting that plain text. On the right hand side we are decrypting that plain text, but right. Here what is that new thing in this diagram is, right, first of all we have studied that ingredients, right? Ingredients, plain text is there, encryption algorithm is there, and secret key is there, shared between the sender and recipient, right? Then on cipher text is there, okay, and decryption algorithms are there. These were that five ingredients for that conventional encryption principle, right? And by using these five ingredients we have drawn this diagram, right? Conventional encryption model, right? Conventional encryption model. But so here the new thing is that, right, you can see that two equations are there, but that mathematical representation of that process, right? Two equations are there, that is called as a mathematical representation of the encryption and decryption process. So very first on left hand side we are encrypting that plain text, right? Very first we are encrypting that plain text on that left hand side. So here plain text is represented by capital X. Plain text is represented by capital X, and cipher text is represented by capital Y, right? So here equation is y equals to e of k comma y, e of k comma x, right? So here y is cipher text. How we are getting that cipher text? Y is equals to, how we are getting that cipher text, right? In mathematical form we are writing, but so e of k comma x, right? So here x is a plain text, x is a plain text, right? On this plain text we are applying and we are taking some key, right? K bit, right? So k is a key, some random numbers we are taking, secret key we are taking, and x is your plain text, your original message. On this pair of key and that x, right, you are applying some encryption algorithm, that is called as a capital E, right? That is capital E. Okay, so in that mathematical format we have written as an y equals to e of k comma x, right? Means we have encrypting plain text, we are encrypting plain text, right, with the help of that key k bit, with the help of the key k bit. Okay, and finally it will produce that y, finally it will produce that y is nothing but a cipher text, right? On right hand side same equations will get reversed. On right hand side that recipient will convert that cipher text into the plain text, cipher text into the plain text. So here plain text is x, so we need to get x, right? So here for that one we need to apply the decryption algorithm. That's why we have written capital D there, x equals to d of k comma y. So here we have to produce that plain text, we have to convert that plain text from that cipher text, right? So on that cipher text we are applying the decryption algorithm capital D with the help of that same key, right? That is called as an asymmetric symmetric encryption algorithm, right? That is called as a symmetric encryption algorithm. Okay, so here mathematically you need to present uh, uh, this encryption model, conventional encryption model, y equals to e of k comma x, right? And x is equals to d of k comma y. Okay, so y here I have explained you. uh, so here you can see that in that way also you can write that equation. In that way also you can write that equation, right? Mathematically we have e, right, ek of x, right, for encryption process, and that will produce that ciphertext, right? Then we are converting second equation, we are converting ciphertext, we are processing that ciphertext, right? Means what we are doing, we are applying that decryption algorithm with the help of the key, right, to reproduce the plain text. Okay, so in two ways you can write that equation. One way earlier I have shown, right, what is that, y equals to e of k comma x, and second equation that is for encryption process. On other hand, for the decryption process you can write x is equals to d of k comma y, d of k comma y. So like this, in two different ways we can represent that encryption process mathematically. Okay, so write that equation, explain that equation, right? Once again, in that equation, y is ciphertext, y is ciphertext, x is plain text, e stands for encryption, d stands for decryption, and same key we are using for encryption and decryption. That's why on both hands, encryption and decryption, we have used that k, right? And x represent that plain text and y represent the ciphertext. X represent that plain text and y represent the ciphertext, right? So by using these ingredients, right, by using these ingredients, or you can say that conventional encryption principle, x y e d k, right, you can write that equations, right? You can write that equation for encryption and decryption also. Okay, next one more thing here, we are saying that encryption and decryption. So in two ways we can do that encryption and decryption, right? In two ways we can do that encryption and decryption. What is that two ways, right? Here uh, we in two different ways we can process the text. In two different ways we can process the text, right? One way is called as a block cipher and another is called as an stream cipher. In two different ways, right, you can process the plain text. Okay, means you can convert that plain text into that cipher text. You are converting that plain text into the cipher text in two different ways. First is block, in that block way, and second way is a stream way, you can convert. So what is block cipher means? Suppose you are having that original message, or suppose you are having some plain text, right, of size one page or one paragraph, right, or one line. So they will divide that message into some fixed size of blocks, right? Suppose 5 characters only, or 4 characters only, or 10 characters only. Okay, so they will divide your plain text into some fixed size of blocks, right? They will divide that your plain text into a fixed size of blocks. Suppose that each block should contains only the 10 characters, only the 10 characters, right? So they will divide entire your message into that block of 10 characters, right? So then the set of the 10 character is called as in one block, right? That set of such 10 characters is called as in one block. Okay, and size of that last block may vary, right? Suppose here you are taking that block size as 10 characters. Block size of 10 characters means each block will contain the 10 characters, but in last block you may have less than 10 characters, right? Suppose 52 characters are there, 52 characters are there. Means what? We need to take the 6 blocks. We need to take that 6 block. First block 10 characters, second block 10, third 10, fourth 10, and fifth also is having the 10 characters. But in last sixth, we are having only the 2 characters, right? Why? Means no more characters are there, and we cannot accommodate that, or we cannot adjust the 2 characters in other blocks. Why? Means the size of the block is only the 10 characters, so maximum 10 characters only we can place in that one. Maximum 10 characters only we can place. Okay, so we cannot place more than 10 characters in that one. Okay, so last block may have some incomplete, right? So that is called as a cipher block, right? So each block will get processed at a time. Means 10 characters, set of 10 characters or block of 10 characters will get processed at a time, right? In block cipher, process one block of character, right, or bits are processed at a time. And that what that block you are processing, and what that block you are giving as an input, right? So for that same block you will get that cipher block also. That set of 10 characters will get processed at a time and will produce that plain text to that conversion of that cipher text. Okay, that is called as in block cipher. Okay, means in group of characters at a time we are processing fixed size of group of characters we are processing at that at the same time, right? And that we will get output for each block independently, each block independently, right? So as just now we have said that 50 total 52 characters are there. For this 52 characters we have taken that 6 blocks. Each block size is 10 characters, right? Then very first, for the converting from that plain text to cipher text, you will give that first block bit, which consists of characters 1 to 10 bit, right? So as this block got processed, you will get that equivalent cipher text for the first 1 to 10 block bit. Not for that all blocks, or not from jumbling blocks, right? Second block will start from 11 to 20, so you will get that equivalent cipher text for this 11 to 20th character, right? Now without touching that 21 to 30 and 1 to 10. Okay, so like this each set of characters will get converted at a time. In stream cipher what happens means each single character will get converted into the plain text. A B C D E F G H I J K L M N O P, that characters are there. Each character, right? Suppose you are writing that Vidya Jyoti, so V will get processed separately, I will get processed separately, D will get processed separately, Y will get processed separately, A will get processed separately, right? So if individual text or each bit is getting processed, right, separately or independently or character by character, then it is called as an stream cipher, right? And here suppose A will get processed bit, right? So you will get that cipher text for A only bit, right? If V is getting processed, so you will get that equivalent cipher text for V only bit. V is separate, I is separate, D is separate, Y is separate, and A is separate. Individually they will get processed, and individually you will get their equivalent cipher text, right? So in two ways you can process the plain text, right? In two ways you can process the plain text. That is called as an block cipher and stream cipher. That is called as an block cipher and stream cipher. Okay, so once again, block cipher is nothing but block of characters at a time we are processing. Some fixed size of block of characters at a time we are processing. It depends on you, right? How much block size you want to take. 8 bit you want to take, 16 bit you want to take, 32 bit you want to take, 64 bit block you want to take. Depends upon that need of that algorithm. Depends upon that need of that algorithm, which algorithm you are using, and what is that need of that algorithm. In that algorithm, right, what I should give as an input bit, right? So we have to give input in the form of block. That one is question is over. Then second question is what will be the size of that block bit, right? So that size of the block can be that 16 bit, size of the block can be the 32 bit, size of the block can be that 64 bit. Means what? 64 bit will get processed at a time. Okay, and stream cipher means one character will get converted. One character will get converted right at a time. Okay, so in these two ways we can process the text. Okay, so this is the second point of today's class, right? One thing we have seen that a model of conventional encryption, right? And in that 1 second we have seen that two equations we have seen how we can process that plain text to ciphertext and ciphertext to plain text, how mathematically we can write, right? And the third thing we have seen is this conversion from that plain text to ciphertext. In two ways that text can be processed. One is that ciphertext and another one is an stream cipher. Okay, so here example is there. You can see that example. Plain text is Raj is boss, right? Readable format is there. Raj is boss. Okay, and we are using that stream cipher technique. Means one character will get converted into the ciphertext. R will get separate conversion to L, A will get separate conversion to T, and J will get separate conversion to S. So Raj, right, is a plain text. Raj is a plain text and LTS is a cipher text. So Raj, anybody can read, anybody can understand. It is a noun, it is a name of the person, right? But on that other hand, after that cipher text, right, it is getting converted into that LTS, right? So they are able to read it LTS, but not able to understand what is mean by LTS, right? Then second is there is there is, right? So I is got converted into P, S is got converted into that N, right? Again that LTS PN, and BOSS boss is got converted into JIKK, right? Even though they are able to read this cipher text LTS PN JIKK, but they are not able to understand, right? So this is called as an stream cipher. One character is getting converted into its equivalent cipher text. One character of plain text is getting converted into its equivalent cipher text, right? Character by character is called as an stream cipher. Block cipher means I will take one complete RAJ as one complete block, three characters, right? Then ISB, right, is as an another block of characters, second block, and OSS as an third character, right? Then these three blocks we will each block, right, will get converted into its equivalent ciphertext. RAJ is separate, ISB is separate, and OSS is separate. Block will be there, block sequence will be there, block sequence numbers will be there. In which order, right, you have transmitted, in the same order receiver will receive that blocks, right? In that same sequence it will receive that blocks. Okay, for understanding again one more example they have given that plain text is Nerala Charivat, right? Nerala Charivat. Okay, and that Nerala Chari we want to process as a block cipher. We want to process as a block cipher. So we have divided that Nerala Chari into that block of two characters, block of two characters, NE as one block, RA as one block, LL AC HE RR as an one block, and finally we have left with only one character. As earlier I have said you that the size of that last block, right, may not be same as that other blocks, right? Always it will be less or equal or less, but not more. Okay, so uh, y is left, no more other characters are there. That's why we have left that block with only one character, right? And it is allowed, right? So we will process each block. In NE is one block, RA is second block, LL is third block, AC is fourth block, fifth block, sixth block, and Y is seventh block. And each block will get processed accordingly. But NE first, RA second, LL third, AC fourth, and that receiver will receive in the same order. and again it will decrypt it. Okay, so that is called as a block cipher, right? And here that stream cipher means one character, C is separately, H is separately, E is separately. In that second example you can say that processing of that stream cipher. Okay, so if your message contains suppose thousands of characters, if your message contains that lakhs of characters also, then it will also get processed individually. C is separate, H is separate, E is separate, right? Or you can go for that block cipher also. Okay, you can divide your entire message, right, into some fixed number of fixed number block size. Okay, so this is that another point. Okay, so you can process our plain text into that two different ways. One is that block cipher, another is an stream cipher. Okay, so model is over, equation is over, and convert the processing of text into that cipher text to plain text to cipher text is over, right? Okay, conventional encryption model we have seen one point. Second point, stream cipher and block cipher we have seen second point, and third is we have seen that equations, right? And again telling that if you write that equation along with that model, that will be the punch point bit, right? Means it will give you some added advantage in getting that full marks. Simply writing the theory means, right, that examiner can easily understand, right? So this in a logical way you write one model, one equation, some examples, like this. Okay, up to here it is clear. Up to here it is clear. Hello.
Yes, sir, it is clear.
So here main is ciphertext, how we are processing that plain message bit, two ways, block cipher and stream cipher, one point, right? And another is we have seen that model of conventional encryption, right? That and equations we have seen. Okay, these three things we have seen, right? So this one we have already completed that key size, right? How much key size we can take, right? 32, 56, 128 and 168 bit. So in most of that encryption algorithm we will use that 128 bit key bit, but in conventional encryption algorithm we will use 32 and 56 bit key only we will use, right? This year also you remember from 1970, right, was the only time period to the invention of public key in 1970, right? Before 1970 we have used only the symmetric key encryption, right? 1970 symmetric key encryption means both sender and receiver they are using that same key. But from that 1970 onwards, they have introduced the concept of public key. Public key means we are having that pair of keys. We are having that pair of keys, right? Out of that pair of key, one key will be used by the sender and one key will be used by the receiver. Okay, suppose example for understanding purpose I am telling you, there are two processes are there. Symmetric encryption is there, asymmetric encryption is there. Symmetric encryption means, right, sender and receiver both are using that same algorithm and both are using that same secret key to encrypt that message or to decrypt that message. Okay, that is called as a symmetric encryption, right? To bring it somewhat more strength to that security, right? From 1970 they have introduced the concept of public key. Public key is nothing but means more than one key we are using. The one key we are using for encryption process on left hand side and another key we are using for decryption purpose on right hand side, right? That is called as an asymmetric. Asymmetric means two different keys are used. So in that one, right, that trusted third party will share, right, a pair of keys with, right, will share pair of keys with. One key is used by that sender and another key will be used by that receiver. So here I was telling you for understanding purpose, it is not an example or not an that things, right? For understanding purpose, I am saying you what is mean by public keyword. So I will send you a message by using your public keyword. Suppose, right, I want to send a message to you, right, by using your public keyword. Public key means you can publicly you can announce this is my public keyword or this is my keyword, right? So that is called as an your suppose Gmail ID. Gmail ID, right? So you can give your Gmail ID to anybody, right? This is my mail ID. Anything if you want to forward, you can forward me on this mail ID, right? That is your public keyword, right? So people will start sending you that mails. People will start sending you that messages, right? People will start sending you that, right? For what you have given that mail ID, that things they will share with you. But how you will see? How you will see? For sending, they will need only the Gmail ID with. For sending, only they will need your Gmail ID with. That is your public key with, and you can share this public key with anybody with, right? But you will not reveal your private key. That is your password. That is your password, right? So people are sending that messages, people are sending that mails, right, with the help of the help of your public key, with the help of your public key, that is your mail ID, right? And you are viewing that messages and you are seeing that messages, right, with the help of that your password, right? If you also don't know the password, if you also don't know that private key, right, then you will not be able to see the messages what people have sent to you. Okay, so that's why they will share a pair of keys with. One key we are using for sending and another key we are using for receiving the messages or decrypting that messages or viewing the content of the messages, right? For understanding purpose, I am telling you, take that example of your Gmail account. Openly in a public meeting, right, I can tell this is my Gmail ID. You can forward your queries, you can forward your mails to this mail ID with. That is your public key with, right? And at the evening you will sit on your system, you will type your Gmail ID and then you will use your private key with what sender have not used, what sender have not used, that Gmail that password you will use, Gmail password you will use, right? And try to see the content what they have sent. So that is called as an your private key. That is called as an your private key, right? So here pair of keys we are using for more security purpose, and that concept was got introduced from 1970s, right? Up to 1970s we have used some, right, conventional methods we have used. Okay, what are the conventional methods, that also I will show you. So remember this one, two types of encryptions are there. But one more point here, fourth point for today's class, symmetric encryption and asymmetric encryption, right? Symmetric encryption means only one key we are using on both sender side and receiver side, right? For encryption purpose and for decryption purpose we are using that same keyword, right? That is called as a symmetric. Same algorithm, same key, that is called as a symmetric. Asymmetric means sender is using its own key, receiver is using its own keyword, right? Or sender is using one key, receiver is using that another key for that encryption and decryption process. Or you can say that for encryption we are using that one key and for decryption we are using that another keyword. So two different key for two different processes we are using, right? That is called as an asymmetric, right? Asymmetric means more than one key or two keys are being used for encryption and decryption process. Okay, and most widely used is symmetric encryption, right? By far most widely used encryption technique is symmetric. Okay, Anything else from here? No. Okay. So we will move to some other document. Mm. So here you can see that one encryption technique, basic encryption techniques I want to show. Right? Is it visible? Right? So that is called as a Caesar cipher. The technique is called, name is called as a Caesar cipher. Right? What we are doing in that Caesar cipher is, right, first of all, here some few points are there. Right? It is that oldest of all the substitution ciphers. Right, very first, or you can say that oldest of all substitution cipher is Caesar cipher word. Caesar cipher word. A Caesar cipher replaces each letter of the plain text with an alphabet word. Right, each letter of a plain text will will replaced by a number word. Right, two examples are given here: A B C D E F G H. Right, up to Z capital letters are there. Right, then we need to select that key means shift. Right, all letters by K. First you select that K may be that 4, K may be the 5, K may be the 6, K may be the 10, K may be the 23. Right, anything K value. Right, if it is suppose what 26 alphabets are there, 26 letters are there, so you can have that key size less than the 26, less than that 26. Right, from 1 to 25 you can have that key size, anything any number you can take as a key size in between 1 to 25. Right, so here example we have taken that k key size we have taken as in 5, that we need to secretly share with that in between sender and receiver. So key is 5, k is 5 here. Right, so here means what? Right, after that when that k is 5 means from this we need to shift 5 places. Right, 1 2 3 4 5, then A will become as an F. Right, A will become as an F bit. Right, see here 5 letters, 1 2 3 4 and fifth letter is F. Fifth letter is F. So whenever you are sending a messages, right, you will tell that recipient that key is 5, K is 5. Right, so here while sending you are adding 5. In below equations you can see here ciphertext is equals to, right, EP is equals to P plus K we are doing. Means in present later we are adding that K value 5 value. Right, so that much what we can say that placements we are doing well. Right, that much movements we are doing well, or that much steps we are going ahead with. Right, so 5 steps you need to go ahead with, and that will be treated as an your first character. So A will become as an F, B will become as an G, C will become as an H, and so on. Right, so our ABCD will start from that F bit. Right, F will be that A, G will be that B, H will be the C, I will be the D, J will be that E, K will be that right. Like this technique we are using to encrypt that message bit. Right, to confuse that attackers what message they have sent. Okay, then by using that one, right, in place of A, wherever A is there it should get replaced by F. Whenever B is there it should get replaced by G. Whenever there is a C it should get replaced by that H. Whenever there is a D it should get replaced by that I. Right, so for this one we can write a simple C program, or we can write a simple Python program also we can write. Right, you can write and practice that one. Okay, means wherever A is there it should get replaced by F, wherever B is there it should get replaced by G. So you need to write logic like that, or you need to write that whenever I am giving some input from that keyboard, whenever I am typing any letter from that keyboard, right? It should be considered as a next fifth character. It should be considered as a next fifth character, and an output it should display from that fifth character onwards, not from that ABCD, actual ABCD, right? So simple around 30-40 lines programs easily you can write in C, or in Python less than that number of lines you can write that programs to convert that plain text into this ciphertext, right? That is called as Caesar cipher. And in one more technique is there in that Caesar cipher is you can replace that numbers. Sorry, you can replace that alphabets ABCD with that numbers, with that numbers. Okay, and whenever you are sending a messages, you can follow this request equation, right? On while sending we are adding that numbers plus k bit, and while decrypting it on that receiver side we have to subtract it minus k bit, right? To plain text we are adding plus k bit, to that cipher text we are subtracting minus k bit. Means what? Suppose you received f but it is not actual f, right? You have received only one character f, but right, that f is not your actual f or actual plain text, it is in cipher text. Then what can be that plain text of this f? Then you need to subtract 5 bit, you need to go 5 steps back, right? So f means e, d, c, b, then you will get a, right? Then you need to think that yes, f is nothing but it is an a bit. So like this you need to decrypt it by subtracting that key value. So for encryptions we are adding that k, for decryption we are subtracting that k. This one also we have seen in the previous classes. Encryption algorithm is there, decryption algorithm is there, both are same algorithm. How you can apply means at what algorithm you are using for that encryption purpose, same algorithm we are using for the decryption purpose, but apply in that reverse direction. Reverse direction means on that encryption time you are taking that plus, then in decryption time you take that minus. You apply that same algorithm but in reverse order, right? But in reverse order, then it will decrypt your ciphertext to the plain text. Okay, so here two techniques are there. One is we have taken as a k is equals to 5, right? Means what? From fifth place you need to start your ABCD with. From fifth place you need to start your ABCD and then edit your messages, then create your messages, so that if anybody see that content, then also they will not able to understand. Just now we have seen that Raj is boss, right? So it's got converted with some other letters, right? So others, even though if they are able to see, they cannot understand the contents of the messages. Okay, so this is that Caesar cipher. One more technique here we will see, and then we will stop. Okay, so here mono alphabetic ciphers are there. Mono alphabetic ciphers are there. Mono means single letter replacement, right? Single letter replacement we can do in mono alphabetic ciphers. One letter is having its equivalent ciphertext, right? So here you can see that ABCD is there, right? ABCD, EFGH up to Z we have written, right? Then key size we have taken as in 23. Key size we have taken as in not 23, 17 we have taken as in key size, right? So at 17th place we got that Q. At 17th place we got that Q, right? So from that place we are starting that one. Q, W, E, R, T, right? I, O, P, A, S, D means Q is now your A bit, right? W is your B bit, E is your C, R is your D, like this one. So here one plain text is there, but I think therefore I am into it, right? Sorry, I think therefore I am. This is your plain text, readable format, understandable format. But after reading that one, you have converted into that O Z I O F A Z I K T K Y, like this. Even though I am able to read it, but I cannot understand the meaning of that one. So here each character will get converted into its equivalent ciphertext. And here we are applying that some formula here we are applying in the Caesar cipher. Okay, so like this substitutions techniques are there, right? And transposition techniques are there, right? In next class we will see that techniques, right? So like this we can convert our plain text into the cipher text, right? Then column transpositions are there in the matrix forms also we can write, and then we can convert that rows into that columns and columns into that rows, right? Or we can hide our text into that diagonals, right? So like this, many techniques, conventional techniques are there to convert that plain text into the ciphertext, right? Then we will see that algorithms, right? What all that other related algorithms are there, how actually C is getting implemented, all those things we will see in that next, right? So here, right, today we will stop. In next class we will see that next topic, or that what are that related algorithms are there, we will see. We have not yet started that algorithm, some techniques we are seeing here, right? How we can convert that plain text into the ciphertext, right? So in two ways we can convert that plain text into the ciphertext, right? Either stream or either that block, right? And in stream we have seen that example, right? How that stream means one character will get replaced, right? So either we can replace with that numerical numbers, or either we can replace with that uh, one character with that another character. So with which character you are replacing it, that is called as a keyword. Means fifth position letters, 17th position letters, 23rd position letters, right? That is called as an your keyword, and that key we need to be keep separate, secret, okay? And secretly we need to transfer it to the receiver will. So here we are adding the position, in receiver will subtract that positions, okay? And it will get that original text, okay? And then we have seen that conventional encryption model also, along with the two equation, encryption equation and decryption equation. Okay, so with this we will stop here. Next class we will see the next topic. Okay, anything you want to ask, any doubts, you can ask. Any questions from your side, or you want to add anything, you can add or you can ask. And one more thing is, some people are there, right? They are simply login, and I don't know what they are doing that other side. And whenever I am calling, they are not responding. Even though if I am waiting after the class for 15-20 minutes also, they are not leaving the class. I only removing from that class. And afterwards they are putting that messages that there is something, some problem is there, that's why I have not posted that roll numbers like that. When I am calling, you are not responding, right? And even you know the class time also 9:30 to 10:30 is there, but even after that 10:30 also you are there in my class.